Whenever you've got a situation where you're comparing two or more things with one another, you're comparing them with one another, you've got yourself what's called a ratio. So we're going to look at ratios in this lesson, and the thing that I want you to understand, number one thing you got to understand in this lesson is how to represent those ratios. You have to know how to represent them on paper with numbers. So let's take a look at this. The best way to learn this stuff is just to do some examples. So we have the ratio of squares to hearts. You have to understand something with ratios in that the order of the numbers matters. So you do have to indicate squares first and hearts second, because that's the order of these numbers. If you were to flip it around, it'd be incorrect. So you have to start with squares. Just count the squares. You got 3 squares. So we have to write 3. And you do have to indicate what that 3 represents. So write squares afterwards. And then hearts has to come second. So we have 3 hearts. We'll write 3 hearts. That's one way to represent them. But there's 2 other ways you can use to represent the same ratio. You can also do this. You can write 3 squares on top of 3 hearts. Now this is not a fraction, because when you talk fractions, what does the denominator represent? The total number of things, right? Do we have 3 total things here in this picture? No, we don't. So this is not a fraction. It's a ratio. We're comparing 2 things. It looks like a fraction, but don't be fooled. And the last way you can represent a ratio is using the word 2. So we'll write 3 squares. We'll write 3 squares to 3 hearts. Now I'm going to tell you right now, you have to understand all 3 ways, but the most useful way, the most practical one that comes up in high school and university, the most common form is going to be the fraction type form. That's the one that's going to be of greatest use to you. However, you still have to understand these ones and convert between them. So let's look at the second example here. Ratio of hearts to squares. Notice the hearts comes first now, so we're just going to flip the numbers around. We're going to write 3 hearts, dot, dot. I'm going to use the dot, dot form here just to save space, to 3 squares. What's the difference between the first example and the second example? Because really we're still comparing squares and hearts. Squares, hearts, hearts, squares. What's the difference though? It's the order of the numbers, right? It's the order that they appear in. The numbers themselves are 3 dot dot 3, but what comes after the number, the words squares and hearts, that's going to be the difference, the order. So now we have the ratio in this third one of red to green. No shape is being indicated, just color. So we have 5 red things. So I'm going to write 5 red, dot, dot. How many green things? We got 3 green things. The ratio of green things to stars. So we have green things comes first. We got 1, 2, we got 3 green things. So how about we write green things in green? We got 3 green. Let's write this one like that. Like a fraction. To stars. How many stars? We got 3 stars. So we'll write 3 stars. Now notice some of these stars are yellow and one of them is yellow and 2 of them are green, but it's not indicating the color. It just asks us for stars. So just count stars. Don't worry about their color. Ratio of squares. Now look at this. We have more than 2 things being compared. We have squares to triangles to hearts. We got all 3 put together. So how do we do this? We got squares first. So we got 3 squares. We'll write 3 squares. We'll write dot, dot. To triangles, we've got 1, 2 triangles. So we'll write 2 triangles. Dot, dot. And how many hearts? Okay, so we'll write 3 hearts. Really? It's that easy, Mr. Melham? It's that easy. I promise you, this is it. So now look at this. We cannot write 3 comparisons, a 3-term ratio. This is called a 3-term ratio. 1 term, 2 terms, 3 terms. These other ones are all 2-term ratios because we're only comparing 2 things. This is a 3-term one. You cannot write a 3-term ratio as a fraction, like a fraction form. You can't write 3 squares on top of 2 triangles on top of 3 hearts and say, hey, this is right. No, it's not right. You cannot do this. This is something we just invented, but it's wrong. So we'll erase it. You can only do the fraction form in a 2-term ratio. And now the last example on this page is we have stars to yellow stars. So we both have stars, but this is a more specific star. This is a yellow star, and this is just stars. So just do what it says. Stars first, we've got 3. We have 3 stars. We'll write ... To yellow stars, there's just 1. 1 yellow. I'll write ST, star. Now we can get into more problem-solving type scenarios. We're going to mix some of the old stuff from the last unit on percents, and we're going to blend it into ratios. But before we do that, let's listen to this. It's like you're right there. It's like you're at the airport. All right, let's do this problem. Let's not waste any time. We have 144 flights. Let's turn it off. We have 144 flights. 25% of these flights were running late. So he didn't say of. I had to say that word of, because when we're dealing with percents, we got to throw that of in there. So we just did it. 25% were running late. 25% of what? Of these guys. Write the ratio of late flights to on-time flights. Huh? Yeah, no, it's not a big deal. Look, late flights is 25%. So we have to find 25% of 144. Now that's not hard because you've learned this stuff already. If you forget it, just go back and rewatch those old videos. Times 144. Let's quickly do this. 0.25 multiplied by 144, and we get 36. So that equals 36. 36 what? 36 on time, right? Nuh-uh. It's not on time. It's 25% we're running late. So these are 36 late. So then how many are on time? All the others, right? Everybody else. So out of those 144, let's get rid of them, those 36. What's left over? Well, we can do some simple subtraction. We can go like this, and we get 108 on time. Okay, so now what we have here is we have to write the late ones first. So we have 36 late, and we have to write the word late. So we know what that 36 means, and then 108 on time. We got one more here. Let's listen to this sound. We have a bus carrying 68 people. At the first stop, now look, you may want to stop this video right now and challenge this on your own. Otherwise, I'm going to keep going. At the first stop, so we have a stop sign, bus. I can't draw an octagon for the life of me. Let's say that's a stop sign. Bus stop. 18 people got off the bus. 18 people got off. And 8 people then got on. Write the ratio of the number of people who are on the bus after the stop. After the stop. So we want the number of people after the stop to those who were on before the stop. So you have to put these ones first, the ones that are on after. So how many are on after the stop? Well, let's think about this here. We have 68 people to start. The bus stops. 18 people what? 18 people got off. They got this subtraction. We have 50 people remaining. But then we had 8 people got on the bus. Okay, so they're like getting on the bus. They're like, hey, everybody, hey, we're on the bus. It's all 8 of us. So now how many people are on? We have 58 people all together. And then the bus starts to roll again and starts moving after the stop. So now how many people are on the bus after the stop? After the stop. We have 58. So we're going to write 58 people after stop. And then those who are on before the stop, well, that's just 68 people. On top of 68 people before the stop.